Imagine a robotic system where every robot doesn't have to do everything. Instead, each robot have a specialist capability and intelligence system decides which robot is best suited for each task. This is our AI-powered heterogeneous swarm robotic system. Our system combines three fundamental different robots: an autonomous exopod, an autonomous six-axis robotic arm, and high-speed SCARA robot. At the center of entire ecosystem is Arduino UnoQ, which act as our master intelligent and swarm orchestra. So each robot has its own subbrain, like the Knight 369 robot has its own Pico microcontroller, and the Hexapod has its own Raspberry Pi with Pico, and the Scaro robot completely depends on CAN control from the UnoQ. Traditional robotic systems are often designed around a single robot performing a predefined class of tasks, but real-world environments are such more complex. Mobile robot may be excellent in exploration but poor manipulation. A six-axis arm can be complex three-dimensional manipulation, but it can't efficiently explore an environment. And a SCARA is efficient in fast and repetitive planar operation, but it's not designed for terrain navigation. So forcing one robot to perform all the other things is not a strength. So it's strength of our project. The key innovation is the way three robots are coordinated. The UnoQ acts as a mission level intelligence of system. It maintains a system state, understands tasks, matches tasks to robot capabilities, allocate missions, coordinate communication, and aggregates feedback from robots. Importantly, UnoQ doesn't need to perform every computational heavy operation itself because each robot has its own microcontroller computing all the other things. It just perform the command sharing. So the hexapod, it is a completely autonomous hexapod which has its Raspberry Pi and lidar. So it could navigate through narrow spaces and do its job. So UnoQ assigns exploration and navigation mission and sets goal for them. So it doesn't need constant control. It just needs low level control from UnoQ. So the next thing is the autonomous six-axis arm. It detects objects through camera, make the icon and send commands to our robot. So visual system process the camera image, detects objects, tracks the target, and convert image coordinate into workspace coordinates through calibration and coordinate transformation. UnoQ receives the manipulation requirements and determines the six-axis arm in appropriate agent. When inverse kinematics is required, UnoQ sends an IQ request to the PC. PC performs the computational intense IQ calculation and returns the joint solution. UnoQ then coordinates the validated result with robotic arm. Then comes the SCARA part. Our third agent is SCARA robot. The SCARA is optimized for high-speed planar manipulations such as pick and place, sorting, and repetitive assembly operation. UnoQ determines the task is suitably they can and dispatches the required task information to the PC. The PC handles SCARA execution and returns the robot status to UnoQ. So the PC is not the master. Complete swarm mission. Now let's look at the complete mission. Locate the object and retrieve. The UnoQ decomposes mission into subtasks. Hexapods move coordinated to the object's move. Similarly, all three could coordinate and move with object tracked. So it is not complete swarm integration, but it does its own job based upon how we train the models and how efficiently we use the UnoQ. This system could be improvised. The task allocator uses robot capability, availability, health, workload, and task requirement to determine the most suitable agent. This means our system is not simply sending predefined tasks, so they check availability. Ultimately, our goal is to demonstrate the intelligent robots doing not have to depend on one powerful robot. Instead, specialized robots can work together on an intelligent physical system. With Arduino Uno Q as a mastermind, three heterogeneous robots become a coordinated, adaptive, and scalable physical AI ecosystem. This is our AI-powered heterogeneous swarm robotic system. Thank you.